requested by some of the students that I put together a video of me explaining and demonstrating how to solve some of these more involved dimensional analysis problems. And so what I'm going to do is step you through these two problems. At any point you want to, you can stop the video and see if you can solve or see how far you can solve before needing to start up again and get my help. All right, the first one is a little longer than the second one, but they both have a good amount of conversions surrounding that central conversion factor. So the first thing you want to do is read through the problem. How many hours would it take to pump the air out of a test chamber with a vacuum pump if the chamber has a volume of 31,250 meters cubed? I give you the dimensions here, but that's not really important. If I hadn't given you the volume, it would be. And the pump can evacuate the air at a rate of 45.0 liters per second. All right, so let's look at what we've got here. First, let's figure out what we're trying to find. And right in the first sentence, you see how many hours. So we're looking for hours, which is a unit of time, as our final number. Now, what are we starting with? We're starting with the volume of this chamber, 31,250 meters cubed. And it just so happens that I have a rate that connects the volume to the time. And so I'll be able to connect those two numbers through this rate. That rate will become my conversion factor. Notice that the conversion factor is a double unit, and each of these, starting number and the ending number, are going to be single units. Also notice that my volume and volume units are meters cubed and liters. So we know we're going to have to do some converting. And my time units are seconds and hours. Again, we're going to have to do some converting. So since we're starting with meters cubed, let's think about a road map. So you know certain things about the relationship between meters and liters and things in between that relationship. So let's suss out that relationship. If we have meters cubed, you know you can get to centimeters cubed. It's going to be a cubed conversion, but you know you can do it. From centimeters cubed, you know that they have that standard conversion from centimeters cubed to milliliters. Okay, and that's in chart B. And then from milliliters, we know we can convert to liters using our standard conversions. So there's that conversion getting us to our conversion factor of liters, or liters per second. So once we get there, we can now, let's switch colors. We can go from liters to seconds, because that's the conversion factor. From seconds, we know we can convert seconds to minutes. And then minutes, we can convert to hours. And we have a 6-step problem. All right, so it looks more complicated than it is. You just have to think a little bit about what you're doing. So let's set it up and make the conversions as we go. Our starting number, 31,250 meters cubed. And we're going to have to multiply that. We have to convert from meters cubed to centimeters cubed. But remember, we can't just cube the units. We have to cube the whole conversion factor. And we do know that 1 centimeter is 1 times 10 to the minus 2 meters. You could use the 100 centimeters over 1 meter. You could use that as well. Either one will work, but make sure you cube it. And then we're going to multiply that. We cancel out the meters, and we're going to multiply that. Now we have centimeters cubed, so we want to convert that from centimeters cubed to milliliters. Don't convert this conversion factor. I'm sorry, don't cube this conversion factor, because we already have the unit centimeters cubed. So 1 over 1, that's your standard conversion. Centimeters cancel here and here. We have milliliters. We need to get to liters. Put milliliters in the denominator, liters up top. And we know that 1 milliliter is 1 times 10 to the minus 3 liters. Again, you could put in 1,000 milliliters is equal to 1 liter. And now we have the unit of liters that we need. And so we can go right to our conversion factor. In the conversion factor, I'm going to put the 45.0 liters in the denominator to cancel out. Notice if you had tried to start with the 45.0 liters per second, you would have had that flipped upside down. And in the numerator, I'm going to have my 1 second. Cancel out the liters, and now we can start converting time. 1 second to minutes, so a minute up on top, seconds down below. There's 60 seconds in the denominator in 1 minute. Cancel out. By the way, watch out for those conversions. It's very common for people to get mixed up and say that there's 60 minutes in 1 second. So make sure that that's correct. Now we want to convert from minutes to hours. So I have hours up on top. I have minutes down below. And I know that there's 60 minutes in 1 hour. Cancel out the minutes. And now I have hours, which is the unit that I'm looking for. And all we have to do is our zigzag math. And when I say zigzag math, remember what I mean by that. Remember, I'm talking about this up and down. We're going to start with our starting number, multiply up, divide down, multiply up, divide down, multiply up. Actually, that divide down should be, let's move that over a little bit. Oh, I didn't want to erase the times or the line. So let's try that again. Multiply, divide down, multiply up, divide down, multiply up, divide down, multiply up, and divide down. Now, in reality, you can ignore those ones. And so what we're going to end up doing is into our calculator, we're going to put 31,250. We're going to multiply that by, or we're going to divide that, sorry. So here's my eraser. Divide that by, now let's do this, let's cube that right now. Cubing that is 1 times 10 to the minus 6. So that's going to be the actual unit you're going to convert with, or the number, divided by 1. And don't forget to put it into scientific notation, 1e negative 6. Times 1 divided by 1, times 1 times 10 to the minus 3. So times 1, let's be consistent, 1e minus 3, divided by 1 times 1, divided by 45, times 1 divided by 60, and times 1 divided by 60 again. Plug that into your calculator, and you should get 1.93, rounded to 3 sig figs. I know my starting number has 4 sig figs, but my conversion factor this time only has 3 sig figs. This is unusual. Don't get used to that. Don't use that as a rule of thumb. It just happened in this particular case. 1.93 hours. So a little under 2 hours to pump the air out of that chamber. Let's look at the next problem. In this next problem, we have a similar thing in which we have to worry about a density, but this time the density is an area density. And so we have the average density of grass in a meadow is 12 grams, 12.0 grams per centimeter squared. What is the mass of the grass, that rhymes, in kilograms that would occupy a meadow whose area is 35 acres? So what do I have here? I want to calculate a mass. Again, that's a single unit. I'm given an area. I tell you area with a unit of acres. And that's also, I don't want to just repeat acres. And so that's also a single unit. And I have this conversion factor that relates the mass to the area. So we've got that conversion factor we need. The only thing we don't have is the exact root to get from our starting number of acres. We need to get from acres to centimeters squared, and then we need to get from grams to kilograms. Well, that one is going to be easy, so we'll save that one for last. In order to get from acres to centimeters squared, I give you 2 conversion factors, acres to hectares. Hectares is the is the metric system, metric unit for area, and a hectare is equal to 10,000 meters squared. So let's think about our conversion, our roadmap. It is almost given to you by the fact that there are two conversion factors here, because we know we have to go from acres to hectares, and then from hectares to meters cubed. And then from meters cubed, as above, I'm sorry, not meters cubed, meters squared. As above, we can go from meters squared to centimeters squared. And once we get from centimeters squared, we can go to grams. And from grams, we can go to kilograms. Oh, look at that. This is also a 6-step problem. So let's get started. We have our area of 3.5 acres. I don't like that. You know what? Let's make it 3.50 just for sig figs. I don't like 3.5 acres. I don't like 2 sig figs. Okay, we're going to multiply by, I'm going to put acres in the denominator, and I'm going to put hectares up top, and 0.4047 hectares in 1 acre. Cancel out the acres. And now I'm going to cancel out hectares in the denominator. That's 1 hectare is 10,000 meters squared. And cancel out my hectares. And now I've got meters squared, so I need meters in the denominator, centimeters up top. And we have, let's do it this way, 100 centimeters in 1 meter. Don't forget to square the whole thing. We'll take care of that again in a moment. Meters squared cancel out, give me centimeters squared. So now I can use my conversion factor. I'm going to put the 1 centimeter squared in the denominator. So in this case, if you had started with the density, you probably would end up getting this correct, but you're never quite sure, and it's not good technique. Let's switch pen colors. And so up on top now I have 12.0 grams in every centimeter. The centimeters squared cancel out. And grams to kilograms is a conversion that you should be able to start doing relatively routinely now. Grams to kilograms, and we have 1,000 grams in the denominator in every kilogram. I'm not going to write out the entire roadmap or the entire calculation for you, but you can do the zigzag math, and 3.5 times 0.4047 times 10,000 times, now 100 squared is again 10,000. So we're multiplying by 10,000 twice, and that's going to give us a large number, isn't it? Times 12.0 grams, and then divide, I didn't cancel out the grams, so I have 12.0 divided by 1,000. I have kilograms as my final answer. And when you do this number, or you do this calculation, you will get 14,200 kilograms, or if you want to put it in scientific notation, 1.42 times 10 to the 4th kilograms. You don't have to, but it's never wrong to put it in scientific notation as long as you do that conversion correctly. All right, let's box the answer up above. Don't forget to box your answers. And that's it for us. So hopefully this helps you solve these problems a little quicker, a little easier. And if you still have any questions, you're not quite sure what your questions are, you're not quite sure how to start problems, meet me in office hours or arrange to meet another time. And that way we can get you straightened out. I will see you in class.